Good morning, ladies and gentlemen. Today we're going to be talking about direct variation and inverse variation. Now you should recognize direct variation. Direct variation, y equals kx. It's the same as y equals mx. It is a slope-intercept form equation. The one thing you know about every direct variation graph is that it goes through the origin because y-intercept is 0. We use k just so we know it's a direct variation. We're very sure, but k is the slope, just like m is the slope. Don't ask me why. Just a joke. All right, y equals kx. That is direct variation. Inverse variation can be remembered as x times y equals k, or y equals k over x. See, now we have a proportion, and if we cross multiply, we get x times y equals k. And that's one way to remember inverse variation. I like y equals k over x. Y equals k over x. So as soon as I see the words inverse variation, I write y equals k over x. As soon as I see the words direct variation, I write y equals k times x. If you do that, you will be on your way. So here's the vocab. Direct variation means the rate of change, which is code for what? Slope. Between two variables is the same. Direct variation will always graph through the origin. In inverse variation, when one variable increases, the other decreases. Here it is, y equals k over x. So here's an example. Direct variation. Remember, as soon as I see those words, I write y equals kx, and then I plug in the numbers. 6 equals k times 3. See, I took this point right here. I took the y value and the x value, put them into the equation, solve for k, divide both sides by 3, and I get k equals 2. Let's try another one. Y equals kx. Take these two, plug in 10 for y, 5 for x, divide both sides by 5, k equals 2. Look at that, I got the same answer both times. That means k is the slope, or in direct variation terms, k is the constant of variation. And in this case, the constant of variation is 2. Okay, figure out the value for k. K is going to be the constant of variation. All right, example 2. Find an equation of variation when y varies directly with x. Look at that. Y varies directly with x. That means I write immediately y equals ax, or y equals kx. You'll see it both ways. Now all I have to do is plug in the numbers. Y equals 12 and x equals 3. I put 12 in for y. I'm going to find out what k is. I put 3 in for x. Divide both sides by 3. K equals 4. Am I done? No, not quite. I need to write the equation. It says find an equation. That means I'm going to write y equals 4x. because I figured out k is 4. It's a 4-step process. Step 1, write y equals ax or y equals kx. Step 2, plug in the numbers. Step 3, solve for k. Step 4, write your equation. Okay, you go through the 4-step process and you write the equation of variation. Y varies directly with x. Tells you how to start. Tells you what step 1 is right there. All right, inverse variation. This time we're going to figure out what k is, but since it's inverse variation, I immediately write y equals k over x. And remember, if you cross multiply, you'll get x times y equals k. Okay, so you can use either one of these. You can use this one or this one. I like using the first one. So I'm going to take this point, put -1 in for y, put -4 in for x, cross multiply, and I get k is equal to 4. If you put -4 in for x here, -1 in for y, you get 4 equals k. We get k equals 4 either way. So the inverse variation is going to be y equals 4 over x. If we tried another point, y is equal to -4, I would have -4 equals k over -1. I cross multiply, and again I get k is equal to 4. So there's my final answer. Once again, it's a 4-step process. Step 1, write the formula. Step 2, plug in the numbers. Step 3, solve for k. Step 4, write the equation. Here's your U-try. Again, this is inverse variation. Start by writing the formula, whichever one you prefer. Y equals k over x, or xy equals k. Solve for k. And here's U-try number 4. Find an equation of variation when y varies inversely. Again, tells you how to begin. And that's the end. We'll work on this some more in class. Variation. I love that phrase, constant of variation. Does that make any sense?